question one is asking me, does the data show the proportion of companies in the first quarter of 2012 that beat estimates is greater than 58% at alpha equals 0.05? Alright, so first of all, you should ask yourself where I am, which type of problem that I am in. So we have our first keyword right here, which is proportion, right? If my keyword is proportion, then what does that mean? Which table that we're supposed to use? Z table, always. Keep in mind, if you're in proportion question, then do not go to the T table. We always use Z table. I'm not sure if Dr. Smith or Dr. Bradman mentioned this in their lectures, but that is how we deal with proportion, right? All right, so my first keyword is proportion, which tells me I'm going to use the Z table. And then, what is my second keyword here? Greater than. Greater than 58%. Well, what does that mean? That is a estimated population proportion. What does that mean? Because we're trying to use the sample proportion to estimate the population proportion. That is what we're supposed to do. Right? We're trying to use the sample average to predict, to estimate the population proportion. All right. So first of all, let's draw the graph. By doing this way, the students in the back can see it clearly. All right. So my P no is called hypothesized value, which is 0.58 in this case. This number is always shown in your HA and HO. So the number in your HO and HA is called hypothesized value. And that is the number you are supposed to subtract by, right? In our formula, we have X bar minus something on the top or P bar minus something on the top, right? So the thing that behind the minus sign is this guy, something null. It's called proportion, null proportion, or mu null, which means this is our hypothesized value. All right, my P null is 0.58, and my keyword is greater than. What does that mean? Shake to the right, or we call it upper tail test. So what is my HO? What is my HA? That is step one for hypothesized testing. Right. So my HO is the opposite of HA. Right? They are opposite. So by given the keyword greater than, I realize that this is the sign that I'm supposed to give it to where? To HA or HO? HA. It's given to HA. And here's another tip. Right? If you have any equal sign, right, based on your keyword, we always give that sign to HO. What does that mean? If you have a keyword less than or equal to, then we give it to HO. If you have a keyword less than, then we give that sign to HA. That is how we deal with it.
Don't you also have to look at like as to reject condoms?
Well, I don't use it that way.
Like rejecting the no or looking at alternatives?
You can use either that way or my way. But I will say on your task, we don't have that much time to figure out what is my word and what is my sign. I always, deal with this kind of question based on the sign only. So if I have greater than, that is for HA. So P bar, this is P. P bar is greater than P and this is P. This is P. P is greater than 0.58. P is greater than 0.58. And HO is the opposite of my HA, which means my P for HO is less than or equal to 0.58. Okay? Now, I figure out my HO and HA. Okay? And some students during this week ask me, hey, Bo, how can I create my graph? How can I tell if this is upper tail or lower tail or two-tail test? And here is the tip. Your direction of your tail, the direction of your tested tail is always in your HA. Only focus on HA. If your HA is greater than 0.85 in this case, then we will have a upper tail test. We'll have an upper tail test. And the probability for my upper tail is given, which is 0.05. Okay? All right. Those are my two first steps. Figure out what my HO is and what my HA is. Create the graph and try to find my critical value. And this point is called Z crit in this case, because we're using Z table. And why we call it critical value? Because it never changes. By saying that, what I mean is this critical value never changes, because this value is only based on the alpha. If alpha is 0.05, then my Z crit is always there. It won't change. Right? And you probably know that we have another number which is called Z stat. And statistic number is from where? From Z table or your formula. It's from your formula, right? So we have two main points. The first one we call it critical value, which is on the graph here, right? And if we're trying to find the critical value, we have to use Z table. Once we find our critical value and try to find test the statistic, we have to use the formula. What is the formula in this case? Is anyone who can memorize it?
X bar minus
X bar?
no, P bar.
P bar minus what?
One minus.
What is my P in this case? It's not P, it's P no. If you go to your formula sheet, it's not P, it's P no, which is hypothesized value. So my P no is given, which is 0.58. What is my N? Q60, right? Q60.
Oh,
260 is my N. Then what is my P bar? What is my sample average? Yes, 166 over 260. 166 over 260. Right? I have everything here. And based on this formula, what I got? The number that I got is critical value or test the statistic. What is the subscript here? Is crit or stat? Stat. Can anyone help me to find this number? One point nine one. 1.91. Am I right? Has anyone got this number? I got 1.909. 2 decimals, 1.91. Alright. And also I want to mention that, well, how can I know what is the scenario or what is the time that I am supposed to keep 2 decimals or z value instead of 3 decimals? The only scenario where you can have 3 decimals z value is when your probability is equidistant from 2. Right? So in this case, because we're not using the z-table, everything comes from this formula. So I keep 2 decimals, which is 1.91. Alright, so my critical value is 1.91, which never